Hello students, welcome to next video. In today's video, I am going to discuss some more topics in beta and gamma functions. So already you have studied the some basic properties of beta and gamma function. In today's lecture, I am going to enlighten you how we use these basic properties while solving the examples. Okay, this plays major role while solving the examples. I'm going to show these properties with some simple examples. Okay, first one, if you want, you can take it as a note. Okay. What we have studied already. First point, we have defined gamma function for n positive integer. Okay, if n is positive integer, so when n is positive integer, what was our formula? Formula was, it is gamma n. First one is gamma n is n minus 1 factorial. Okay, or same thing, you can write it as in place of n, write n plus 1, then it becomes n factorial. Whichever is convenient while solving problem, you can use that. Okay, for example, if I have 5, okay, if you are given with 5, gamma 5 find out ಮಾಡಬೇಕು ಅಂತ ಅಂದ್ರೆ ಯಾವ್ದು ಈಸಿ ಆಗುತ್ತೆ ನಿಮ್ಗೆ? n minus 1 factorial easy. Okay, gamma 5. So we are going to use this. n minus 1 means 5 minus 1 factorial. So 5 minus 1 is 4 factorial. 4 factorial can be written as 4 into 3 into 2 into 1, that is 24. This is how to calculate the given gamma of any number. This is for positive integer. You may ask, you may have doubt. Suppose if I have a negative integer, what happens if n is negative? Okay, if n is negative, already you know we have defined beta and gamma functions for positive of n. So n greater than 0 only. No need to worry about this. But still, one must know why we are not taking negative integers as. We are not taking negative integers. Why? Because for negative integers, gamma n, to calculate gamma n, we have to consider gamma n plus n 1 divided by n. If n is less than 0. So we'll check this. For example, if I want to find gamma minus 4. So what happens according to this? Gamma of n plus 1. N is minus 4. Minus 4 plus 1 divided by minus 4. We have to keep calculating this. Okay. Minus 4 plus 1 is minus 3 by minus 4. Again apply gamma n formula. So what? Minus 3 plus 1 divided by minus 3. Now minus 4, n is minus 3. Okay, so it is minus 2 divided by plus 12. Again minus 2 plus 1. Minus 2 plus 1, 12 into minus 2. So minus 2 plus 1 is minus 1, minus 24. So again formula minus 1 plus 1 divided by minus 24 into minus 1. So what it is? Gamma of 0, even though I get positive value here, but gamma of 0 is what? Infinite. So it is infinity. So what it implies, for negative integers will not get the values. So that's why we are not taking any negative integer. Okay. Next, third one. Suppose if n is any fraction, okay, in that only also consider it is a positive fraction. If n is a positive fraction, in such case how to find the gamma of n? Okay, so for positive fraction, when n is positive fraction, again we are using gamma n formula. Here, to find if n is a positive fraction, then gamma n is n minus 1 into gamma of n minus 1. Okay? We use this formula. For example, if I want to find gamma of 5 by 2, this is our fraction. Okay. So according to this, n is 5 by 2. 5 by 2 minus 1, gamma of 5 by 2 minus 1. You have to apply this formula repeatedly until you get the answer, and you should not continue when if it becomes negative. Okay, you have to stop at the last positive value. So 5 minus 2, 5 by 2 minus 1 is what? 3 by 2 of gamma of 3 by 2. This is nothing but, again, apply for this gamma of 3 by 2, apply this formula. So it is 3 by 2 into gamma of 3 by 2 minus 1. It is 1 by 2 gamma of 1 by 2. But as I yesterday told, we need to prove some other properties. We have considered gamma of 1 by 2 is equal to root pi as a standard property, because we are using that value here in place of gamma of 1 by 2. Previously ಮಾಡಿದಂಥ ವಿಡಿಯೋದಲ್ಲಿ, ಲಾಸ್ಟ್ ವಿಡಿಯೋದಲ್ಲಿ ನಾನು gamma of 1 by 2 equal to root pi ಸ್ಟ್ಯಾಂಡರ್ಡ್ ರಿಸಲ್ಟ್ ಅಂತ ಹೇಳಿದೆ. ಯಾಕಂದ್ರೆ while solving the example solve ಮಾಡಬೇಕಾದ್ರೆ ನಮಗೆ gamma of 1 by 2 ನಾವು frequently use ಮಾಡ್ತೀವಿ. In place of gamma of 1 by 2 we use root pi. So now it is what? 3 by 4 and gamma of 1 by 2 is root pi. This is the solution. As I said, remember, we should not continue here gamma of 1 by 2. ಇಲ್ಲಿ ಬಂದ್ಮೇಲೆ ಮತ್ತೆ ಈ ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡೋದಿಲ್ಲ, ಯಾಕಂದ್ರೆ n minus 1, 1 by 2 minus 1, it becomes negative. So we should avoid gamma going to negative. Okay. Now, suppose one may ask a question, if n is a negative fraction, whether so one may have a question whether if n is a negative fraction, what happens? Okay, if n is negative fraction, then you can find the value of gamma. For that, as I said, we use gamma of n equal to gamma of n plus 1 divided by n. Okay. For example, we'll see one example. If I want to find gamma of minus 5 by 3, gamma of minus 5 by 3, put the values here. So gamma of minus 5 by 3 plus 1 divided by minus 5 by 3. So what happens? Simplify minus 5 by 3 plus 1. It gives you minus 2 by 3. Gamma of minus 2 by 3 divided by minus 5 by 3. Again, apply formula for this. Minus 2 by 3 plus 1. Minus 2 by 3 plus 1 is gamma of 1 by 3 divided by minus 5 by 3 into minus 2 by 3. Okay. So this is, if you want, write one more step. Minus 2 by 3 plus 1. Then in the next step, you can write it as gamma 1 by 3. And here it will be 10 by 9. So you can stop here now. You will get a positive answer. Gamma of 1 by 3 divided by 10 by 9. Or else further you can write it as 9 by 10 into gamma 1 by 3. This is the answer. This is how to find the negative fractions, gamma of negative fractions. Okay. One thing easily you can remember, if you have a positive fractions, formula is n minus 1 into gamma of n minus 1. If gamma of n is a negative fraction, the formula is n plus 1 by n. Okay, means for positive you have a negative formula n minus 1, n minus 1. For negative fraction you have gamma of n plus 1 divided by n. Simply you can remember like this. Okay, we'll see some more examples on this. Before that, we see any two other major basic properties. We are going to use them in solving examples. So next property is gamma n into gamma of 1 minus n is equal to pi divided by sine n pi, standard result. Okay. And sixth one, integration from 0 to pi by 2 sine raised to p theta into cos raised to p theta d theta is equal to gamma of p plus 1 by 2 into gamma of q plus 1 by 2 whole divided by 2 times gamma of p plus q plus 2 divided by 2. Okay. This depends on the powers of sine and cos. Simply. In particular, if in the above equation, in particular, if you put p and q, so here it is q. Okay. If you put q as 0, if q is equal to 0, what happens in this equation? Integration from 0 to pi by 2 only be left out with sine raised to p theta d theta cos raised to 0 theta. Okay. So RHS expression becomes integration, gamma of p plus 1 divided by 2. Okay. Whole divided by q is 0. Gamma of 1 by 2 whole divided by 2 times p plus gamma of p plus 2 by 2. This is nothing but gamma of 1 by 2 is root pi. So it is gamma of p plus 1 by 2 divided by gamma of p plus 2 by 2 into square root of pi by. In the same way, if you put p as 0, p is equal to 0, then integration from 0 to pi by 2 cos raised to q theta d theta is equal to gamma of q plus 1 by 2. We'll directly write the formula. You know how to calculate this. So q plus 2 by 2 into square root of pi by 2. Okay. These are some standard results. Now, as I explained how to calculate the values of n when it is positive integer, when it is a positive fraction and negative fraction. We'll see some more simple examples how to calculate. Okay, some simple examples we'll check. First one, gamma of 3 by 2. Okay, gamma of 3 by 2, how we are going to calculate. It is, what is the formula? Gamma of n is n minus 1 into gamma of n minus 1. So n minus 1 is 3 by 2 minus 1 into gamma of 3 by 2 minus 1. Go on calculating with me only so that you can understand very easily. So it is 1 by 2 gamma of 1 by 2. 1 by 2 gamma of 1 by 2 is square root of pi. So it's nothing but square root of pi by 2. So next, second one, we'll check one more example. Gamma of 11 by 2. So gamma of 11 by 2 is 11 by 2 minus 1. Gamma of 11 by 2 minus 1. Okay, what it is? 11 by 2 minus 1 is 9 by 2. And it is gamma of 9 by 2. We go on expanding this using this formula. So Shall I write it directly? 9 by 2. 9 by 2 minus 1 is 7 by 2. Again, 7 by 2 minus 1 is 5 by 2. 5 by 2 minus 1 is 3 by 2. So 3 by 2 minus 1 is 1 by 2. Lastly, it is 1 by 2 into gamma of 1 by 2. When you simplify this, you get 945 divided by 32 into gamma of 1 by 2 value is root of 5. Okay, understood? Now, we take one negative fraction, gamma of minus 1 by 2, simple value, minus 1 by 2. So, as I said, if it is a negative fraction, we have to consider RHS as n plus 1. So, gamma of n plus 1 divided by n. So, n is minus 1 by 2 plus 1 divided by n, that is minus 1 by 2. Minus 1 by 2 plus 1 is plus 1 by 2 divided by this is minus 1 by 2. Gamma of 1 by 2 is root pi, minus 1 by 2 is minus 2 root pi. Only we should not get negative values for gamma. Okay, here if you get it, it is okay. The solution. Now we'll check one more. Gamma of minus 5 by 2. Again, minus 5 by 2 plus 1 whole divided by minus 5 by 2. So minus 5 by 2 plus 1 is minus 3 by 2 divided by minus 5 by 2. Again apply the formula. Minus 3 by 2 plus 1 divided by, already we have minus 5 by 2. Again it's n, minus 3 by 2. So minus 3 by 2 plus 1 is minus 1 by 2. Here it is minus into minus plus 15 by 4. Minus 1 by 2 plus 1 divided by 15 by 4 into minus 1 by 2. So it is gamma of plus 1 by 2 divided by minus 15 by 8. Gamma of 1 by 2 is what? It is root pi. So it is, and minus 15 by 8 is minus 8 root pi whole divided by 15. Okay, this is the answer of gamma of minus 5 by 2. We'll move on to next example. Suppose if you ask to evaluate 6 into gamma of 8 by 3 divided by 5 into gamma of 2 by 3. How you are going to evaluate? Keep 6 as it is. Gamma of 8 by 3 is what? N minus 1 into gamma of n minus 1. N minus 1. N is 8. 8 by 3 minus 1 is 5 by 3. Again, gamma of 5 by 3 is 5 by 3 minus 1. So it is 2 by 3. 2 by 3 minus 1 is, you will get a negative value. So we have to stop here. So gamma of 2 by 3 whole divided by 5 into gamma of 2 by 3 already you have. So gamma of 2 by 3, gamma of 2 by 3 get cancelled. Okay, this 5 and this 5, then 3 and 2. So what you will have with numerator, denominator 3. So 4 by 3 is the answer. And in the last video, we arrived at a formula that beta of mn. Now, if you ask beta of 5, 6, what is formula? What was the formula? Beta mn. Beta mn we derived as gamma of n into gamma of n divided by gamma of m plus n. We use this. So here m is 5, n is 6. So gamma of 5, gamma of 6 whole divided by gamma of 5 plus 6. So it is 11. Gamma of 5 is what? Gamma of 5 is n minus 1 factorial. Okay. N minus 1 factorial is 4 factorial and it is 5 factorial. Gamma of 11 is 10 factorial. So simplify the factorials and you will get 1 by 12, 60. Now, suppose beta function with fractions. Beta of 9 by 2, 7 by 2. So same formula, 9, m is 9 by 2, n is 7 by 2, divide by m plus n. 9 by 2 plus 7 by 2 is what? 16 by 2. Apply the gamma function. For 9 by 2 it is what I said. For positive fraction it is n minus 1 into gamma of n minus 1. Okay. So it is 7 by 2. For 9 by 2 it is 7 by 2, 5 by 2, 3 by 2, 1 by 2 into gamma of 1 by 2 for first one. For 7 by 2 it is 5 by 2, 3 by 2, 1 by 2 into gamma of 1 by 2. All divided by gamma of 8, 16 by 2. So 1 by 2, gamma 1 by 2, gamma 1 by 2 is 5. Then next simplify all this. So multiply 7 into 5 into 3, 5 into 3, 5 into 3. So we will get 1, 5, 7, 5. But as we are not able to cancel all this, that's why just multiply. 2 into 2 into 2. Okay, how many times? We have to 7 times. So it is 128. But gamma 8 is 7 factorial. This is how to solve given beta and gamma functions with the n. If you are given with some n and m using these two properties, whatever you have studied in the previous video, gamma n equal to root pi, gamma of 1 by 2 equal to root pi, we used that. And also the one more property is gamma of n is n minus 1 factorial, that is also we have used. And what else we used? We used the another form, that is a gamma n for positive fraction. Gamma n is n minus 1 into gamma of n minus 1. And for negative fraction, what we have used? Gamma n as gamma n plus 1 by n. Okay, these are all the basic formulas you have to remember. If once you are perfect with this, then you can solve any of the examples in beta and gamma functions. So in the next video, I am going to discuss some more standard examples on beta and gamma functions which are important as your exam point of view. Okay, till then keep practicing all these formulas and practice these simple examples. If you have any doubts, please comment in the comment box. If you are not yet subscribed my channel, do subscribe and support. Till then, take care. Thank you.